Hello friends, welcome, and if you haven't subscribed to my channel till now, then please subscribe it now, and I hope you all will enjoy my videos. So in this video we are going to build a simple recurrent neural network using TensorFlow, and we are going to build a simple neural network that will going to convert the binary number into the decimal number. So it's going to be a decimal to binary converter. So now let's begin with our code. I'm going to write all the code in Python. First of all, I will import all my libraries: OS environ, tf, cpp, min, log, level, spelling mistake, and string. Next is numpy as np. So first of all, we are going to create a dataset for our converter. So let's first define a function that will convert a binary into a decimal number. It will take a binary number as a list. First of all, we are going to convert this list into the string bin str k in bin list bin string, concatenating the string k. And now we are going to return the decimal value of this binary number using this int function bin str, 2. So now let's test it. Bin to int, and we are going to provide this a list like 1, 0, 1, and its value is 5. As you all know, 1 plus 4 is 5, so its value should be 5. Python, so you can see its value is 5. Now let's do one thing, make it 0 and check if its value is 4. So you can see it's giving correct result. So now we have the function. Now we'll create another function named dataset. It will help in creating a large amount of dataset. It will take num and the bin length as example. Num is the number of examples we want to generate, and bin length is the specific length, a fixed length of the binary numbers. Like if you want binary number of length 8, then it will generate number num rows and bin columns. Now let's define some numpy arrays: zeros, num, and bin length, and y. X will contain the binary numbers and y will contain their decimal number. So this function is going to create a list of random number size bin length between 0 and 1. So let's print it out and check it. What does it print? Dataset, like num if want to generate 10 of size 8. See what's happened? So you can see it has generated binary numbers. Now let's generate its decimal number. bin to int and the xi y. Oh, so let's see what's the problem. So we can see this error here, and the error is that we need to convert that int to first k to int, and then we can see we have generated the binaries as well as their respective decimal number. So now we can just do simple thing. We can just we have got our a list of not list and numpy array, and we will return it x comma y. Now our dataset is complete. Now we will import our TensorFlow LSTM. Next we will import the RNN. TensorFlow dot contract import RNN. Now why this is red? TensorFlow dot contract dot RNN. That should not be a problem. Let me check and run this. Invalid syntax. Okay, it should be from. That's my mistake. Now we'll define some of the parameters. Len x len. This is the length of the binary number which we need to be generated, and the number of samples. I want to generate 1000 samples of size 8. Learning rate, like you want to say 10,000. Display step, like you want to say 1000. Next is the network input, and input is xlen, then time step. You only need one time step, the hidden number of neurons, let's say 16. The number of output is only 1, as we have only one decimal number. Now let's generate the training and testing data set. Train x is equals train x comma train y is equals to data set. Here we can say it requires first number, that is number of sample, and then xlen. Testing data set test x test y should be equal to data set number of samples, say 5 of xlen, same length. Now we will add the graph input, placeholder tf dot float 32. Here we will say none time step and n input, and like this we will create y also, placeholder float 32 and none and n output. So we have created our graph input. Now we need to create the weights. Tf dot variable and tf dot random normal, n input, or not n input, I am wrong, it should be n hidden and n output, and the bias variable random normal and output. Okay, now we will define our RNN function that will take input, weight and the bias. First we'll unstack the input x time step comma 1. Next we need to define the LSTM. So we have a simple function here, tf.unstack. So what this does is it unpack the given dimension of R rank R tensor to a rank R minus 1 tensor. So it reduces the rank of the tensor by 1. Next LSTM cell RNN dot basic LSTM cell, number of hidden unit, forget bias 1.0, outputs states RNN dot static, RNN dot static RNN. It will take LSTM cell input and the type should be float 32. I'm going to return some values, matrix multiplication of the our last output, last value of output, and the weights W, adding bias with it. Next logits RNN x weights and bias. Next we need to reshape our data according to our input. Train x should be equal to np dot reshape train x, and that is -1 to time step to an input. Okay, train y should be equal to np dot reshape dot train y, its shape is going to be -1 and the n output. And like this we need to also change the shape of the testing data also. We'll just copy it and paste it. Just change some simple thing, test x, test y, and here also we need to change it to test s and test y. Rest all the thing remains the same. And now we will write our the loss function. It's going to be simple loss use mean mean squared error, and it take logist and the y real answers. Now the optimizer is equals to tf.train dot prop optimizer, and it take learning date. Now the training step optimizer dot and minimize. So we need to minimize our loss using our optimization function. Now we'll create the session to train and test our data, and here we'll initialize all the global variables. Let's do one thing. We will run it and check if till now there's any error. Minimize. So we got an error about the spelling mistake, MINIMIZE, and let's check once again. So this time no error, so this means that we are going correctly. No errors are there. For step in range training steps, I haven't defined the training steps. Oh, I just make a mistake. Learning rate should be 0.01 and training step should be 10,000. Now you can see training steps here. Those session dot run the training step and the losses step. If we did to give it the data, x should be the train x. I'm just giving all the variables directly. I'm not creating a batches. You can create batches and you will get the better performance, but our data set is not so huge and it will give us a correct result in small amount of time only. If steps plus 1 percentile display step is equals to 0, then displays the result. Print step should be step plus 1. Loss should be equal to loss. Print optimization finished. Now here comes the testing part. We have finished out our optimization, and let's see and run it. It is an error till now, so you can see we have an error. The shapes incompatible shape 8001 versus 1001, and let's see how we are going to solve it. Number of steps 1, display step thousands, and I don't seems to find any error in the shapes. Let me go above and see. The error is here. The training x begins from here. Let me check here only. Mean squared loss, it's correct. Now it's correct also. Check the learning rate 0.01. It's okay. The training step okay. Optimizer minimize, optimize RMS, and now the loss. Let me just pause this video here and the problem I solve. You can see that's giving us correct results, and our loss starts to reduce, and ultimately we just our minimum loss is 0.131365. Now we will check our training. Result is equals to session dot run targets and predict is equals to x test x print real answer. This is the guess or the predicted answer. For I in range, you just compare both the answers. We have I think 5 data samples. Okay, 5, and then 5. What we're gonna do next is the print both the answer. First is real answer, that is test by dot I, and give a blank space and an arrow. The result I. Oh, it should be between those. And let's run it again and see if there's any error or it runs successfully. And if it's run successfully, how much correct answers it give to us. So you can see these are our real values and these are our predicted values. 195, 194.66, 253, 252, 200, 199, 1. So you can see we are just near the answers. what we can just do is we can just round off them and see if any changes occur. After round off we will get a correct value. It will just round off all these values after the decimal. And we will also increase the number of training steps to get the correct performance. We just compared the previous. It's 4 and 0, same we can say. So you can see if we have got a correct result in some cases, and in some cases we are still lacking behind, like in the last one we are still lacking behind. If we just change it to 10, we increase the number of testing data to 10, and just increase the number of steps, training steps to 20,000, and give us result after every 5,000. So we will definitely get this time correct result. 100% accuracy means previous time we have only 90% accuracy. Our one of the answers was wrong. It will just take a little bit of time greater than the previous one, and you can see this time we has greater data set, 138 to 138, 127 to 127, 125, 125, 38, 38, and the next are also same. So you can see this time we have got every result correctly. Now let's see if we just increase it to 20. We can also make a function to just compare both of them. If both are equal then it's good, both are not good, then increase the number of steps. You can also introduce the dropout layer here, but we do not need it now because we are getting correct result already, so no need to. You can increase the learning rate, like what we have 0.01, so you can increase it 0.001 also. It will improve your performance. So you can see I think all our results are same. Let's just do one thing. If test y I equals to test, no test, it's result I, then print true, else print false. And in case of false we want to see the result. In case of true we don't want to see it. So you can see we are getting some of the result as false, and they are just behind one value. Just one value is they're greater than one value. So this is 239, this is 240, 15, this is 16. Let's do one thing, increase it to 50,000, and this time definitely we'll get every result correct. We are now on 30,000, 35, and now 40, and our error reduces a lot, and now on 50,000. Come on. So this time we have only one false result, so we can say that our 99%, we have got 99% accuracy. You just need to just tune up the hyper parameters of your neural network and you will get the result. I hope you all like this video and understand the concept which I'm trying to explain to you. If you like this video, then hit the like button and share it with your friends. And thank you. Have a nice day.